This is section 2.8. You can see I have some graph paper here, so we're going to be doing some graphing. We're going to be graphing inequalities. And before we do that, I do want to do a little review of how to graph a line. So we'll review slope-intercept form, how you count the slope, how you plot the intercept, what your different slope lines should look like, and all those sorts of things. And then when we are done with that, we'll take a look at some examples with linear inequalities, which are going to be very similar. You should have received some graph paper in the mail. So if you wanted to pause the video and go grab that graph paper, it would probably be a good idea to go through these examples and write them as I do them. Or maybe you just watch the video now, come back and watch it again later to take your examples. So you decide what you want to do. So like I said, we're going to talk about slope-intercept form. So we did this earlier. All right. And you can see I have an equation in slope-intercept form. So y equals mx plus b is our equation in slope-intercept form. And when it's in this form, the m, so whatever numbers in front of the x will tell you what your slope is. And this number at the end here where it says plus b, that will be your intercept. All right, so I want to kind of just go through a couple review things. What should a line look like if it has a positive slope? What should it look like if it has a negative slope? And then also, what do your horizontal and vertical lines look like as far as their equations as well? All right, so a little review to kind of get you back into graphing lines. So the first example I'm going to do here, we're going to take a look at a positive slope, okay? And this equation is already in slope-intercept form. All right, so we have y equals 1/2 x plus 2. All right, so again, the number that you see at the end here, so I'm going to circle this number here, it says plus 2, that is my y-intercept. So again, my y-axis is the one that goes vertically. So on my y, I'm going to go and I'm going to put my dot, I'm going to count up to 2. I'm going to go ahead and put my point there. All right, once I have that point on there, then I'm going to go ahead and I'm going to use my slope. So again, the number in front of the x is my slope. And we like it to look like a fraction because again, we think of those words rise and run. So if I have a 1 on the top, that means I'm going to rise 1, I'm going to run 2. All right, so from the point I put on my graph, which is going to be my starting point, from here we are going to count up 1 square and then we count over 2 squares. Okay, I'm going to go ahead and put another point there. And if you have room, I usually go at least another time if I can. I'm going to go up 1 square and over 2 squares. All right. So now I got 3 nice points on there. And I'm going to grab my ruler. And we go ahead and we have our line. And again, one thing to kind of double check to make sure you're counting your slope when you're all done is to take a look at your graph. If my slope is positive, when you read, like from left to right, if you trace along that line, your line should be going up. Okay, that's kind of a quick check. Make sure you at least counted and your line is going in the right direction. All right, the second example I have is something that has a negative slope. So again, if we think about what I just said about the positive should be going up. So the opposite of that, if you think about this line, my negative slope, when I get done graphing this one, we should notice that the line is going downward again when you look at it from left to right. All right, so my equation this time, we have y equals negative 2/3 x plus 1. All right, so again, I'm going to always start with my intercept. My intercept is a positive 1. So on the y, we go ahead, we put our point on the positive 1. My slope is negative 2/3. All right, so again, this is my rise and run. Since it is negative, rather than going up, I'm going to go downward. Once you go downward, that takes care of the negative, okay? So I'm going to go down 2, 1, 2, and then I'm going to go right 3, 1, 2, 3. All right. And again, if I had room, I would maybe go again, down 2, 1, 2, 3. Okay. And we have 3 points. So again, I'm going to grab my ruler. Go ahead, we make our line. And again, like I said, we take a look at this one, and from left to right, if you were to trace over it, you can see that it's going down. So again, positive should always go up from left to right. Negative should always go down from left to right. All right. The two other lines I want to take a look at, they're kind of the special lines. So they're going to look a little different, and you just kind of have to remember. And what you have to do here again is just kind of think about, you'll notice that this equation here, it just says y equals 2. You'll notice this equation here says x equals 3. So in these two examples, you'll notice there's only one variable. All right. If you look at the first two examples I did, you'll notice you have both a x and a y in there. Okay, so these are going to be a little different. So in this one here, where it does say y equals 2, okay, so we just have to remember which one is the y-axis. So the y-axis is the vertical axis. So what I'm going to do is I'm going to go to 2. Okay, I'm going to put a little point right there. All right. Now, what this means is if my y value is 2, it has to go through the y. Okay, so once we have our dot on 2, we can draw a nice horizontal line. Okay, and that means every value on this line has a y value of 2. Okay, so if it says y equals 2, nice horizontal line through 2. If it said y equals -4, we would go down to our -4. We'd have a nice horizontal line through -4. All right, so that's what your horizontal looks like. The vertical, again, is going to be kind of the opposite of that. You'll notice this time it says x equals 3. So again, if I go to my x-axis, so my x-axis is going horizontally here. I go to the x, I go to 3. Go ahead and put my point there. And again, this time I want to draw my line through the point. Okay, I don't want to draw right over the x-axis again. I want to go through the point. And that's why this time my line will be vertical. Okay, so I have a nice vertical line. Again, every point on this line would have that same x value of x equal to 3. All right, that's kind of a little review. We've done this before. Okay, so again, positive slopes should go upward, negative slopes should go downward. If you have an equation that says y equals with no x at all, that means you have a nice horizontal line. If you have an equation that just says x and you have no y at all, that means you're going to have a nice vertical line. All right, and that's the information we're going to use now that we are talking about inequalities. All right, so let's take a look at some things I have here. All right, so first thing, I just have a little list of things I want to talk about and go through. And again, you can pause this and copy these down or come back to them later if you'd like. To graph inequality, you're going to follow the same steps that we just talked about for graphing a line. Okay, so my first thing here would be to go ahead and put it in slope-intercept form. If your line is already in slope-intercept form, you are ready to go. If it is not, you may have to do a little extra work and try to get the y so that it's all by itself. All right. The difference between the inequality and the equations that we graphed is that you're going to now see the symbols we've been talking about in our last couple of lessons. You see greater than or less than, greater than or equal to, and those symbols there in place of the equal sign. All right. So if you have greater than or equal, okay, so again, if it's greater, we're going to do some shading, and that means you're going to shade the graph everything above your line that you graphed. Okay. If it is less than or less than and equal to, again, think about less. Less means you are going to shade everything below your line. Okay, so you're gonna, like I said, put it in slope-intercept form. You're going to make your graph, and then the only difference is now, again, you're going to be shading that graph. All right, a couple of key things, and again, this is similar to what we talked about when we were shading just number line graphs. Sometimes you have to pay attention to whether or not it has that little equal sign or if there's not the equal sign. All right, so if it is greater than or less than, when you make your graph, you're going to make a dashed line. Okay, if it is greater than or equal to or less than or equal to, then you're going to go ahead and make a solid line. Okay, so you do have to pay attention to that when you make your graph. Okay, one key thing, and again, this goes to the same thing we talked about before when we were working with our inequalities, if you do have to rearrange your inequality or do any kind of work to get it into your slope-intercept form, remember that if you ever divide by a negative number, you must flip that inequality symbol. Okay? And will include one of those examples so that you can see what that looks like. All right? So let's take a look at, I've got 4 examples here for you. All right, so the first example that we're going to start with, we're going to go with something that's already in slope-intercept form just to kind of get us going here. So example number 1, we have y greater than or equal to 3x minus 2. So again, already in slope-intercept form, we can go ahead and start making our graph. So we're going to go to our -2 on the y. So again, I'm going to count down to -2. I'm going to go ahead and put my point there. All right, my slope says 3. Again, I always like my slope to look like a fraction, so I am going to go ahead, I'm going to put my little 1 under there. So my slope, I'm going to say, is 3 over 1. So again, thinking of my rise and run, from my point that we already put on our graph, we are going to count up 3 and over 1. All right, so 1, 2, 3, and 1. And if we got room, I'm going to go again, 1, 2, 3, and 1. All right, so once you get your points on here, we're going to go ahead, we're going to make our line. And again, this is the point where you have to be careful and pay attention to what I just mentioned up here. If it do I need to make a solid line or a dashed line? So this one does say greater than or equal to. So I know I can at this point make a solid line. So I'm going to go ahead and do that. All right, and now I need to figure out where I want to shade. Okay. So if it says greater than, I want to shade above the line. All right, so that means all of this over here. Okay, and again, similar to when we shaded a number line, that means there's many solutions. All my solutions are going to be in this section of the graph that I shaded. Okay, you could always pick a test point and plug it into your inequality if you're unsure if you shaded the right area. Okay. All right. Number 2. All right, this one, it just says x is less than 3. Okay. And again, if we think about slope-intercept form always says y equals. This one doesn't even have a y in it. So again, this is kind of one of those special lines that I just talked about on the front. All right. So if it just says y less than 3, I'm sorry, oops, x is less than 3, sorry. I'm going to go ahead and go to the x, and I'm going to go to 3, 1, 2, 3. I'll go ahead and put my point there. And again, everything has to be 3. So again, this is where I'm going to draw my vertical line through the 3. And again, before I draw my line, I want to think about this. Should I make it a solid line or a dashed line? This just says x is less than. It doesn't say equal to. So for this one, we do need to make a dashed line rather than a solid line. All right, so that's what I have so far. Now, in my explanation of where to shade, I always said above and below. Well, now the X is kind of a special one because there really isn't anything above or below because it's a vertical line. So this one, you just kind of have to think about it a little bit. Think about what it says. If this says X is less than 3, where would all the numbers be that are less than 3? This is 3. This would be 4. This would be 2. So if I want all the numbers less than 3, that means I need all of these over here. Okay, so all of these numbers in this section of the graph would have a value of x less than 3. All right, so when you get to that type of problem, sometimes you just have to stop and think for a second. All right, example number 3. Okay, this one we have x plus 2y less than or equal to 6. Now this one is not in slope-intercept form. So that means we need to do a little work. We need to get the y all alone by itself on the left side. So the first thing I want to do is I want to take this x and move it to the other side. This x is positive right now, so we're going to go ahead and we're going to go minus x and minus x. All right, 2y less than or equal to. And now it says 6 minus x. These are not like terms, so I can't really subtract them. Okay. I'm going to keep the x in the front though, and there's a minus sign with it. So I'm going to put minus x, and this 6 is positive, so that means plus 6. All right. We still have this 2 in front of the y. This is 2 times y. I need to divide everything by 2. All right. So our final equation or inequality in slope-intercept form, we have y less than or equal to, and I'm going to write this as negative. We can put a 1 in the front of there, negative 1/2 x, and 6 divided by 2 is a 3. So we now have our inequality in slope-intercept form, so we can go ahead and make our graph. My intercept is 3. So again, on the y, we're going to count up to 1, 2, 3. Go ahead and put our first point on there. My slope is negative 1/2. So again, if we think about what we talked about, we know our line should look like it's going downward. We're going to go down 1 and over 2. Down 1 over 2. Down 1 over 2. Since we have less than or equal to, again, pay attention to that. We can make a solid line. So I'm going to go ahead and draw in my solid line. All right, go back to my problem one more time. It says less than or equal to. So less than or equal, I'm going to shade below my line. So again, everything in this section of the graph would be a solution to my inequality. And again, like I said earlier, if you're not sure if you shaded the right part, you can pick a point and plug it in. A lot of time, like if I was going to check this one, most people think 0 is an easy number to check. So what I would do is I would take the point 0, 0, which is in the shaded section, and I could plug it into my original inequality and make sure that it's okay. So if I put in a 0 for x, a 0 for y, and ask myself, is that less than or equal to 6? This would be 0. This would also be 0. 0, is that less than or equal to 6? And it is. So that means we know we are shaded in the right section because that is everything in this section here. All right. All right, and last example. This one we have negative y less than 2x minus 1. So it's looking pretty good in that it's almost in slope-intercept form. We do have the y over here, which is where we want it. We have our x over here. However, right now there's a negative sign in front of the y. So what we want to do is, this would be like a negative 1 in front of there. We don't want that negative with the y. We want it just to be y. So what we're going to do is we're going to go ahead and we're going to divide everything by negative 1. All right. And if I'm going to divide by a negative, as I mentioned, we now have to make sure that we flip our inequality. All right. So negative divided by negative, this is now positive. So we have y. I need to flip my inequality, so it's going to change from the less than to greater than. Here we have a 2 divided by a negative 1. So I'm going to write that as negative 2x. Put the little 1 on the bottom. And here we have a negative divided by a negative. That will give us a positive. All right. Now, as far as this negative sign here, technically you could leave it in the denominator if you want. I usually like it in the numerator just because I think it's easier to see there. Excuse me. All right, so now we are ready to graph. Our y-intercept is 1. Okay, our slope is negative 2 over 1. So down 2 over 1. Down 2 over 1. It says greater than, does not say equal to, so we are going to have to make a dashed line this time. Greater than, we are going to shade above. All right. There you go. Good luck.